Today we're going to look at function fitting. We're going to look at function fitting. We're going to look at it for 2 lectures because you will see it again. You've probably talked about it before in other classes. I'm hammering it home here again just because there's a mathematical perspective, but it's a really important idea. If you have data at all, you will be doing fitting at some point in your lives. So I just want to show you how, A, technically we can do it in MATLAB, and B, some of the gotchas that can happen if you just naively use tools like MATLAB or Excel to do the fitting. So, data files. You've already done a little bit of this from week 1. We're going to do a bit more of it today. And just to reinforce the idea that MATLAB is frequently used for analysis of data that comes from somewhere else. Most of the stuff we've done has been internal to MATLAB, but usually you have files coming from some other client, customer, off-site resource, and then you have to bring them into MATLAB or some other software to use them. So there are a whole host of ways to bring files into MATLAB. We're not going to spend a huge amount of time analyzing different file formats, but I just want you to recognize that there are a bunch of file formats out there. The most common are the ASCII-based files. If we look at a file, and let's go to Documents. Actually, let's go here, Math 272, go to our notes. And what I'm going to do here is look at an Excel file. But I'm going to open it with something else. I'm going to try to open it with something else. More options. I'm going to open it with Notepad. All right? That is what an Excel file looks like when you open it in Notepad. It looks like complete and utter, well, it looks like crazy garbage on the screen, quite frankly. That would be a binary file. In other words, it's not meant to be readable by a human being. Okay? It is encrypted, or not encrypted, it's represented in some complex way that Microsoft came up with for Excel files back in the day. And basically, you can't read it unless you've got Excel. I'll contrast that with, whereas other kinds of files that you'll get would be commonly called text files, text, TXT, CSV files. They will look, if you open them in Notepad, if I open this in Notepad, it'll look the same. It looks like readable information. We can kind of understand at a glance what is going on in this file. The reason we usually like ASCII files is because anybody can open them. Any MATLAB, Excel, any software will understand what a text file is. The converse is not true. Not everyone will understand a binary format. And so, especially if you're going to mining, there will be specific CAD/CAM design binary file formats that no one else can understand. You often have to export to something more like this before you can actually use it in some other software package. And you often lose something in translation, too. But for data, this kind of file, a text file, an ASCII file for, I can't remember what it's called, some encoding of letters to numbers. This is the standard for safe transportation of tables of data around. Every piece of software will get this. And you can open up a Notepad and go, yeah, my data's sane or not sane. So that versus that. That's the on-the-ground difference between a binary file, which is encoded somehow, but no one else, you have to know the encoding to unencode it, versus a text file, which is a standard data format that pretty much any software will understand. All right, so that's the high picture. What I'm going to highlight here is that these 3 files here read text or binary, non-binary files, text, ASCII files. Now, the only variation on them is how we interpret them as tables. So if we look at this table, it's separated by, actually we can't really tell, but it looks like spaces in between. It looks like it's tables of data. I can see there's column titles at the top like in an Excel spreadsheet. But in between, like what's the gap between this number here and the date that follows next and the time that follows next? There's usually some separator. And here it happens to be tab characters, as it turns out. But let me just do a quick export here. We're going to open this with Excel. So this is what looked like craziness in Notepad, but Excel knows completely what to do with it, so it looks completely reasonable in Excel. We can save this as, file save as in Excel, and we can save it in the same folder And you can change the format to a whole bunch of things that include text Notice it'll say tab delimited. So that means there's a tab between everything in the comma, everything in a row, or comma delimited. This is another very popular choice. So now what we see is there's an Excel file, .xls, and there's the exported version of the CSV file. If I open the CSV file in a text editor, it looks like the table in Excel, a little less easy to read because it doesn't space things out. But you can see it's a number and then a comma, number, then a comma. And so it's a comma-separated variable file because all my variables are separated by commas. It's a very what you see is what you get kind of file format. And Excel can open these and do stuff with them, stuff like that. These are more limited. Excel has multiple worksheets, can have formulas. CSV files are just data in columns, so it's a little more restrictive, but it's universal that everyone and all kinds of software will understand it. All right. Not a major theme of the course, but just something that it's important to know if you're getting a data file in, and secondarily to know that there would be appropriate input things in MATLAB specifically that read Excel files, which are binary files, versus reading a generic text file with a separator in them. We're going to take advantage of the XLS read because we'll have an Excel file, and we'll see how that works. All right. There we go. We're going to make a new file. We're going to call it W58. I'll just save it here. That'd be great. Let's do that. Load in the quiz test data. So the nice thing in MATLAB is it's got some searching ability. So first off, I just make sure that I'm in the right directory. I look over here on the left and make sure that, yes, indeed, my file, my Excel files are all visible here, and so I can access them. And as soon as I start typing, capital Q here, I can press the tab button. So this is pressing tab. It'll try to autocomplete, so I don't actually have to type in all the things, all the letters. And it gives me a choice here, actually, so I can just arrow down and say, that's the one I want, thank you very much. And it's good policy to include the XLS extension, because some other Excel files have the XLSX for the more modern Excel versions. And that's a good place to start. Remember, that's a crazy file, so this may not work on the occasional person's computer. You need Excel installed. MATLAB doesn't know the binary format for Excel, so it actually says, here's an Excel file. It passes it off to Excel in the background. Excel figures out what the tables are and then passes it back to MATLAB. So if you can't run this, if it gives you an error, it's most typically because Excel isn't actually installed in your computer. So we run this, and lo and behold, we see that table that we saw in Excel, but now we see it in MATLAB. So we actually have a matrix of data here, lots of rows, 2 columns. And what we typically do with this is not just display it, but give it a name. Let's call it D for data. All right. And just to contrast, seeing as we have the CSV file, file, text, not binary, you would say D is equal to CSV read of the same thing except with a CSV extension, and that would give us the same answer. Oops. Actually, we do run into a problem if we try to read the CSV file. And this is, again, not a major theme of the course, but something that if you ever deal with a data file from somebody else, you'll hit this. What does it sound like it's complaining about? Yeah? How the file's delimited. Actually, delimited is probably OK. I'm thinking about the third line down here. What does it sound like it's looking for? Numbers, yes. What does it just run into? Text. That's it. There's a very incredibly common problem. If you look at the Excel file, there's a header. So we actually can look at this and know, oh yeah, the first column represents quiz grades, the second one represents exams. So that's a very common thing to do. But MATLAB doesn't handle data files as elegantly as it might. And so somehow we have to tell it those first, just ignore those. I know they're quiz grades and exam marks, but just ignore that first line. Just give me the numbers that come in after that. And so that's where you go to your help menu and say, how do I clean this data up a little bit? Well, we go to the help for CSV read. And hopefully it'll tell us something. Aha. It does indeed. So we're trying this first format where we just read this file. And then it goes, bleh, I can't read that file because that first row is text. You can delete the row of text. That's perfectly reasonable. But it's nicer to actually handle it inside MATLAB so later on you can go back and remember what those columns are. Reads the data from the file starting with a row offset and a column offset. So we can say skip the first row, skip the first column, then start reading stuff. So we can just tweak that a little bit. We're going to say let's skip the first row. Sorry, I have to close that. We're going to skip the first row, but we don't want to skip any columns. And that should read our file in without any errors. Just clear the screen here for a sec. Run. Exactly. So now it runs fine. That second line is doing the same thing the first line did with a little bit of massaging to make the file read work correctly. The XLS read has a default, sort of looks for text lines and then says, oh, I'm going to skip those. The CSV is a little less robust, a little more fragile, but you can control it with some options.